Okay, so let's get started with the CAD aspect of this webinar. Today I'm going to show you how to design a denture using Dentca's web-based denture design, which is actually a pretty slick product. I'm going to be using their sample files, and I'm going to show you where you can get those same files so that you can, after this webinar, go ahead and download those and get started with this program, which is free to use and free to design. And you only pay when you're happy with your design and you want to print out files. So if you scroll down to the bottom of the page on the Dentca design, you'll see download sample files, and that's what I did. These are the files that I'm going to use. It's just a maxillary cast, mandibular cast, and a wax rim. So let's get started with that. We start by hitting denture design, and here it's asking me to log in. And go back here, denture design. So this is the upload page, and we're going to start by importing those files. And as I get to these sections where it's going to take up a little time, I'm just going to pause the video and go ahead and take care of those so we can move along with our seminar. So I'll pause here and I'll put those in. So I've uploaded the maxilla and the mandible, and just so you can see how this process works, now I'll go ahead and I'll do the bite. I'll hit the browse button. I'll enter the bite here, hit open, and then upload the case. Okay, from here we get to this demographics page where it's just going to ask some basic information about the type of case that we're doing and the kind of setup that we want to do. We'll input the patient's initials, gender. This is where the example we're doing today is actually a complete denture, but obviously if you were doing an upper or lower, you would specify that there. It's not an immediate denture. And these are the scan types. This is the type of media that you've uploaded. In our case today, this is the selection that we would pick. Dentca has a solution where you can actually do the impressions in tray and bite in one appliance, I believe. And this discusses the anterior overjet, the type of teeth mold that you want to use. You have a lot of different options for the types of teeth that you have. Here's the teeth arrangement. You can specify by standard. If you want to give it a masculine or feminine flair, you can do that as well. Here we can specify the type of occlusion you want to use, lingualized, anatomic, or no change. And for a denture setup, I'm going to go with lingualized for a full set, but if I was just doing a single arch against natural teeth, I might go for anatomic. Festooning style, post-dam, and our basic options. And of course the most important one, the Ackuretta printer, because we're going to be using the sole to produce our parts today. Okay, so I went back in, I filled out the form accordingly. These are some of the options that I picked out. I'm using the Mondial teeth, regular anterior overjet, masculine teeth style. Festooning is going to be standard, 1mm post-dam, printed, Ackuretta printer, and no post-dam, no crossbar, sorry. Okay, once the form has been submitted, we're going to get to the first of 5 steps that are pretty easy to do. The first step is to match the bite compared to the other additional casts that we've uploaded. So we'll start with the maxilla, and one thing I find that's pretty helpful is if I orient the cast in the same direction to begin with, and then go ahead and make my marks. In this case, I hold the control key down, I make a mouse click where I want to enter a dot, and then on the corresponding cast, I'm going to put them in the exact same positions. If you get to a step and you get a little bit confused, this guided tour button will launch a little video which will show you the same steps and give you some best practices as well. Once I'm happy with the marks, I go ahead and I do the same thing for the lower arch. So here again, I hold the control key down. I'll make my marks. You can do it in any order you want, just as long as you're clicking in the same spot on each part of the different casts. From here, it's going to give us this screen, and it's going to show us our alignment between the bite rim and our casts. And here we've got such a perfect mesh, it's hard to see any differences. But in general, you want to make sure that the purple here is in the same plane as the orange, and that's how you can tell you've got an ideal mesh demonstrated by this. We'll hit confirm here, and then it's off to step 2. In this step, we're actually going to mark out the borders of the base plates. So for here, we hold the control key down again, and we left mouse click and start selecting where we want our border to be. I go through the vestibule. When I get to a frenum, I make sure I follow the frenum so that our base plate will not encroach on that. Okay, so once you've created your spline, you can go around and review your outline, and if you find an area where you need to refine it, simply click on the dot, double mouse click on the dot, and move it into position, as so. Next, we're going to do the same thing for the mandible. Okay, and here I've done the same thing for the mandible. Now, if there's an area where you'd like to add a dot, you can also just double mouse click right where you want to add the dot, and it will add the dot and move the spline for you as well. Once you're happy with that, we'll go on to step 2. Once we hit validate, this dialog box will appear, and this is showing us where we have our flanges set up for our base plates. And if we're happy with this design at this point, we can go ahead and hit confirm and move on to step 2. In this step, we have to mark some landmarks for the maxillary mandibular cast. For the maxilla, we're going to want to mark the incisive papilla with a control and a left mouse click, the tuberosities, and it's helpful if you move the cast around to get your orientation for these types of things. Now I'll just do the mandible. Here we're going to do the retromolar pads, and basically we want to be halfway up the pad to help with the occlusal plane. It's 1 and 2. Okay, this screen is a rehash of something we've already filled out, but again, we have the opportunity to make some changes if we saw something on the cast that might influence our decision. For the most part, it's pretty straightforward, but again, gives you a lot of flexibility in terms of how you want your final design to be. Okay, it'll take about 4 or 5 minutes for this section to render with our selections. So while that's going on, I'm going to give you a quick tip on how to find the patient's vertical dimension. Okay, while we're waiting for that to compute, I wanted to give you some tips and tricks throughout this whole presentation. And one of them that's pretty important is that you know how to find the patient's vertical dimension when they're edentulous. It turns out that there are some golden proportions of the face and hands that you can use to actually determine what this number is. And I want to show you how to do that. First, if you take your thumb and your forefinger and you almost make a gun out of it, and you put the tip of your finger under your nose and your thumb under your chin, you'll find that it almost matches perfectly. And in fact, that's your vertical dimension. So for somebody who's edentulous, you can have them do the same thing, put back pressure with their mandible down onto their thumb, and you're going to have a pretty accurate representation of where their vertical dimension is. Another thing that you can use is you can take some calipers and measure in between the corner of one eye to the inner corner of the other eye, like that. And that dimension too corresponds to a patient's vertical dimension. And you can test these things out on yourself, and they're pretty darn accurate. So those are just that's just a handy tip to know when you're doing removable. A lot of it is forensics and figuring things out, but there's actually some well-known things like that that will help you out to get those dimensions. Okay, so now that the design has rendered, we're going to go through some quick verifications. This first one is just comparing the mesh of our maxillary mandibular cast to our bite. And again, I'm looking at the purple and the orange, and I'm making sure that they're in the same dimension as I rotate it. And this is an excellent mesh. We are spot on with this. This is pretty ideal. We have the opportunity to take away the bite, one of the arches, and these are just visibility things that will make our job a little bit easier when we do the next step. The next step, in fact, is to look at our outline. I'm fine with that. And then the occlusal plane. This is the first time we're going to use the shift key, and I'll show you what to do here. So we want to line up our midline. I'm going to hold down the shift key, and then it's going to give us some arrows, and now we can sort of orient the midline with this red line, and we can adjust the occlusal plane as well. So here, I'm going to hold the shift key down again, and now I'm just going to move the occlusal plane so it's about parallel with the occlusal plane, and then just left mouse click to bring it up. And then we are pretty much in our approximate dimensions. Now, one thing I'm noticing here is I want to move the wax rim, and I can see that my occlusal plane is a little bit high because I actually want it to be halfway down the retromolar pads. So I'm going to grab my occlusal plane, bring it to the retromolar pads about halfway down, bring back my bite, and now I'll use the shift key again simply to bring that occlusal plane back up to this. And so now I'm feeling pretty good about that occlusal plane compared to just where the wax rim was. Okay, now we're getting to the teeth selection. This is going to be a bit of a guess with this software. You can take some measurements of the patient's edentulous arch and make some better predictions ahead of time. But for the most part, if you're dealing with a standard patient, let the software predict what it thinks is good, and you can make changes from there pretty easily. Okay, so this was the tooth proposal by Dentca, and as you can see, it gives a pretty good, very ideal setup for that matter of the teeth. And it's been my experience that I have to make very few changes from the initial proposal design that it gives me. So it's pretty fast to use this program, and it's got a pretty slick interface, as I'll show you. If you do have to make some changes, you've got some group selections here at the bottom which allow you to select a certain section of the teeth at a time, and you can operate just on those teeth. You can operate on a tooth individually. You can operate on an entire arch for that matter. Here, for the most part, you just use the shift key, and it'll bring up a wheel where you can change the orientation of the teeth in different dimensions. And this was very well thought out. If I make a change here in this dimension, this is from the facial, this is the same thing from the top, from the side, you can get some pretty granular things. And of course, you've got the undo, which is pretty important if you make some changes that you don't like. On the right side here, we can make some changes as far as we can remove the second molars by toggling this switch here, and the premolars as well. And we can add them back in. Okay, so once we're happy with our design, we can go ahead and submit this for a final SO. It's going to go back and it's going to give us some of the same options in case we've changed our mind. But once we hit confirm, it will go through a rendering process. And this process could take anywhere from 30 to 60 minutes depending on what's happening with the Dentca servers and how busy they are. But that's time that you could go ahead and design another case if necessary, or move on to some other things. So I'll go ahead and I'll let that finalize, and we'll move on to the CAM side of the program, which I'm pretty excited to talk about, Accuretta's Alpha 3D software. Okay, this screen is for managing your Dentca projects. And once your case is completed, you'll typically get an email from Dentca letting you know that your case is rendered and it's ready to go ahead and purchase your STLs and download your parts. So initially what will happen is it'll say completed. It'll let you look at the parts, and if you're happy with it, you can go ahead and purchase the parts so you can produce them. After you've done that, you'll get this download tab, and you'll see a screen that looks like this. And these are all the individual files, original files, and then one file which is zipped and contains all the different files. So we're going to move ahead, and I'm going to show you what that looks like once you unzip it. Okay, so this is the screen that you get when you unzip your files. You get a lot of files, and I'm just going to quickly explain what they mean. AIO stands for all-in-one. So for example, a lower all-in-one is the teeth as well as the base plates in one complete file. You might want to do this to do a try-in, and the reason why you might want to do a try-in is the try-in resin is a little bit less expensive than the permanent resins, So you could do a try-in in the mouth. If that's good, then you can go to the next stage and print it out with your permanent resins. And obviously, if it isn't good, you can go back and make some changes before you spend the money on the permanent resins. Other than that, you also get the individual parts of the denture. Lower dB would be the base plate. And then you get the teeth in 4 files. One is the complete teeth, and then the other one is in sections, anterior, left, and right. There's reasons to do this if you're milling or printing, because you can save space if you're doing it in sections versus a whole arch in a puck. That's why they provide it to you that way. But you can print it all as one piece, or you can print it or mill it in sections. You could even mill this base plate from what they give you. Okay, so let's go ahead and bring up Alpha 3D now, and let's go through the camming side of the program. So Alpha 3D, I really enjoy using this program. It's pretty easy to use, yet at the same time you can get pretty granular with your settings to help you print things and make some tweaks as you get to know the program a little bit better and want to get a little bit more efficient with your printing. But in general, I'm just going to sort of give you some tips and tricks to get you on your way so that you can be up and running with some successful printing. The software is really divided into 3 planes: setup, support, and slice. In setup, this is where you'll bring your items in and orient them. Support is where you add supports to your item and nest them. And then slice is where you'll create the job and then send it off to the printer. Let's get started. I'm going to import some denture teeth. We'll do the bottoms to start. And I'll bring this all in as one complete arch. Now, you're going to want to orient these so that the the denture teeth side, the occlusal side is down. And by using the scroll wheel, I can move this plane around as such. And then the right mouse will pan and bring it this way. So first, I'll go ahead and I'll set it down. We've got it occlusal side down, so that's looking pretty good. And then it's okay if we've got a little rise there. That's helpful. So now I'm selected the sole printer. We're going to be using Dentca resin. We're going to be using shade A1, and I'm going to print it in fine resolution. So now we're going to go off to support. And here we can go to the specific application. So I'm going to select bridges and then auto supports, and it will generate supports based on a pre-programmed thing. So that's pretty quick and intuitive. Now I'll show you a trick here, and well, let's go over some printing math. Okay, so it turns out there's a bit of a paradox when it comes to printer math, in that the amount of time it takes to print a layer is fixed. For example, I know that using this resin, printing in fine detail, it'll take me about 16 seconds per layer to print this object. And it doesn't matter if I duplicate this object 3 or 4 times on the same build plate, it's going to take the same amount of time to build all objects as it does the first one, because the time is in the platform moving to the next position is what takes the most time. The cure happens very quickly. So if I orient this part vertically instead of horizontally, and let me show you what that looks like. I've gone from basically 200 layers to almost 400 layers. So I'm printing the same part, but at the same time, it's going to take me twice as long to build that part. And that's sort of the dance that you get into when you start to nest printer parts, is you want to print them efficiently so that they're going to print, yet at the same time, you want to save as much time as you can to do your print. As you get flatter or more horizontal, for example, let's go ahead and do that one back again. When this prints, one drawback is that I've got a lot of surface area on my build platform versus here. So that means that there's the opportunity for this surface area to stick to the platform and or stick to the vat instead of the platform and break away. As it turns out with denture teeth, you're pretty safe in this orientation, and that's why I like using my 3D printer so much, is I can prototype pretty quickly. In this case, it'll take about an hour to finish this job. I'll go ahead and I'll add the supports back. And then I'll go through an exercise that's very important for you to know. Let's turn this upside down. This slider is going to show me the layers as they're printing. So initially when I move it up, everything in blue is going to be pertinent to that particular layer. When I go through and I'm testing my part, what I'm looking for is these areas of red as they're forming, and I want to make sure that there's a support under the area of red. If it's not, it's called an island. And when you get those islands, that's a potential area where it will not print. So as I'm going through my design, I can see the red and I can see I'm well supported. And by going through this exercise then, I'm pretty confident that I know that this part will go ahead and print successfully. And once I've verified and I'm happy with that design, I'm going to go to the next part, which is slice. Now, in this area of the program, this is going to generate the file that the printer is going to use to create all the slices and build your part. And it's also an area where you can actually start to duplicate these parts. Like I said before, it takes the same amount of time to build one as it does two. And that's the nice thing about 3D printing, is it may make more sense for you to print a couple of copies of the part that you're making. You're not losing any time, but at the same time, when it comes to finishing, if there's a problem there, you've already got another part ready to go. So here I'll do save and slice. It's going to create the file for me, and then I'll show you how we can go ahead and send this to the printer from there. So I'll let that go through its calculation. Okay, now that it's finished, it brings up the Explorer, and I can see that it's created two files, an IBF file and a 3DP file. The IBF is actually the printer file, and this is the project file. So if I want to bring this up again, I could import this IBF file, and I would see exactly what I'm seeing right here. But let's go ahead and launch the printer, and I'll show you how to print this file. I'm going to go to Manage, and this is going to bring up a dialog box, and it's going to show me all the printers I have available. I click on this, and the Soul Printer interface is actually web-based, as well as it's on the printer as well. So I go back to my file, and we'll go ahead and we'll drag and drop that file over to the printer. And there we go. I'll hit ready. It's looking for the printer, and it's telling me this print job will take about an hour. So now I would go to the printer. I'm going to show you that next. Go ahead and launch the job. And before I do that, I'm going to show you how to clean the vat and go through some just typical printing hygiene that will help you be a little bit more successful with your print. So let me go ahead and turn around. I'll get to the printer now. Okay, so this is probably something that would go under tips and tricks. I'm going to show you how I do a cleaning cycle. I do this before each print. It burns about $1 worth of material before I get started, but you know, if you're going to do a long print like a denture base or teeth, it could be up to 3 hours depending on how you orient your parts. It's definitely worth it to get this done instead of wait 3 hours and then find out you had a misprint. That can be pretty disappointing. So to do a cleaning cycle, I get these silicone spatulas. You can get them anywhere that's cheap. They don't have to be anything special. And I'll just move it through the resin, make sure there's no lumps or bumps. Just kind of get it there. I try and be very clean with the resin. I hate resin spills. And on that note, if you see these papers here, these are pee pads that you can get at any pet store, and they work great. They keep the resin on the top part. It never soaks through. It works just fine. So, and then I don't mind laying an instrument down when I have to as well on that, and I know it's going to be okay. So once I do that, I'm going to run a cleaning cycle. So I'm going to close the lid here, press down on that lever, and what this will do, I'll hit this button here, and I'll do this. So this will go ahead and it'll cure the very bottom layer of the tray. It'll clean the tray, and then I'll be sure that I've got, clean resin in there for my print. So I'll show you what that looks like in just a bit. Okay, so the cleaning cycle is done. For this, you want to use a plastic spatula, never metal, and basically just start on one end and wait till you can kind of lift up the piece. And I gently slide it in here. I lift it up. I always wear gloves usually when I do something like this. I have these little disposable trays here that I keep handy for discarding parts like this. And so that I don't make a mess, I let it drip a little bit and then immediately move it to here. Okay, so now I know my tray is clean, my resin's good, and I'm ready to go ahead and start printing. Okay, so now I'm at the printer. This is the print job that it sent to it. I'll simply hit print. And we're off. And here's a quick tip too. When I go ahead and I click on the job, it's going to show me all the different layers that are printing as it's going through it. And it's saying, here it's 441 layers and what have you. Okay, so now that we've handled the teeth, let's go ahead and print a denture base, and I'll show you how to do that aspect of it. Again, we go back to import. I'll do the maxillary denture base. And again, here we always want to print occlusal side down. What's different about a denture base versus the teeth is you've got a tremendous amount of surface area here. And also we have the intaglio of where we want our teeth. So we're going to have to make a speed compromise by orienting this part so that it can print at a favorable angle and try and keep the supports out of the intaglio of the denture base as much as possible. When you're doing a denture base, ideally you want to be at about 70%, an angle of about 80 to 70 degrees. And again, I'll sort of cheat it this way to keep the supports away from the intaglio of the tissue surface and try and minimize the supports ending up in the intaglio here. Again, this time I'm going to change my resin to denture base. I'm going to use fine. Now I can move to support, and I'll go ahead and I'll choose denture base for that. And let's just see where I end up with doing this. Okay, so I can see how it's going to nest it. It's a whopping 800 layers almost, so I know that this job is going to be about 2.5 to 3 hours. But let's go ahead and let's go through the slicing just to make sure that we're going to get a good print. And again, for a 3-hour job, it pays to spend a few minutes here just to make sure that you're good with where you want to be. Incidentally, I'm flipping around here, but you can hit these views as well and it'll instantly go to where you want to get it. So here we're looking at the top, which is where you want to be. I'm starting to see my red, and I'm seeing good support around it at all times as it's building. Again, I'm looking for any red islands that might be forming without support. I know that that won't happen if I don't have it. And this looks very good to me how I have it. So this should print nicely. We'll go ahead and we'll go to my slice now. And we'll go ahead and save and slice. And it'll go through, it'll produce that part. And then we'll send that to the printer. As soon as the teeth start printing, we'll go ahead and we'll print this part too. I've made some copies of this denture base, and I wanted to backpedal a bit to talk about one other aspect of printing, and that's about resin pooling. When you orient a denture such as this, it's going to start at the build plate, at the top of the build plate, and work its way down. the way I have it oriented, you can see that there's really no opportunity for resin to pool up in the denture base, versus if I flipped it going the other direction, not only would that possibly end up with supports on the intaglio, but I could end up with resin pooling, which could also cause a misprint. So just another tip is before you're about to print, orient your part so that you can see it, how it would build from the build platform, and just try and envision the resin flow, and hopefully see that your resin is going to drain pretty easily from the part. Okay, so let's see how we did. And here's our denture base on the platform. So now we will demonstrate the next step, which is the cleaning, which is the cleaning station from Ackuretta. So we remove it from its base, and then we can simply transfer it to the first chamber of the cleaning. And it'll fit just like this. Like so. This will clean the platform too. Now, one thing to note, you can clean it for 3 minutes. I like to clean it a little bit longer. And once that's finished, I'll do the same for the next side, and then we'll go ahead and we'll cure it. Okay, after the first wash, I'll remove it from the platform, and then we'll go ahead and go into the second wash. So, and then I'll let that run for another 5 minutes. Okay, so this is out of the second cleaning. I went ahead and I removed the supports, which actually come off pretty easy. And I can see that there's some spots in the intaglio where I'll probably have to hit it with a little round burr before seating the teeth in there. But overall, it's a very clean print. Tissue side is beautiful. And now we'll go ahead and we'll put it in the Curie. I'll just set it down like this, and we'll run it. It's about 5 minutes in this unit. And we'll let that go ahead and cure. Okay, so now that our parts are assembled or printed, we can go ahead and assemble it. And what you'll see here is that they fit pretty much like little pieces of Lego. They just kind of snap right in place. I'll be using some of the pink denture resin to set them, but first I'll just try everything in. And last piece. And we have a few screws to knock off there, but for the most part, that's going to fit pretty well. And you'll see how the resin will flow in between the teeth and form a seal there. So I'll go ahead and I'll do this next step. I'll just drip some resin inside the intaglios, set the teeth, and then I'll go ahead and I'll cure it in the Curie. And as you can see, I'm just painting the intaglio here with a little of the pink denture resin. And I'll continue on with that for the whole arch. Okay, so here's where we're at. We painted resin inside the intaglio of the denture surface, and now I'll go ahead and I'll fit the pieces and the teeth parts inside of that and wipe away the excess resin. Okay, so I've set the teeth, and now I've gone around the marginal areas. I've flowed in some more resin, and I've sealed that, and I'm likely going to go back in with some Gradia after that, just to spruce it up a little bit. But for now, I'll go ahead and I'll cure it, and then we'll see where we're at. Okay, so this is after bonding. We've already got a pretty nice result here, but I'm going to try and spruce it up. I'm going to use some Annex Gum Flow and just add some pink in between the teeth and some red just to spice it up a little bit. I don't want to spend too much time on this because, you know, as it gets more labor intensive, well, it begs the question of why not go by hand. So I want to do things that are cost effective and time efficient for you, and I think this is going to add a nice little touch to it. So let's see how that goes. Okay, so here is the completed denture. On the right half, I went ahead and just added some annex gum, some gradia, some Optiglaze, just to give it some characterization and show you how you can warm things up. And on the left side, I just did a coat of Optiglaze, and that's going to help keep the teeth from staining. Anyway, it'll keep them a little bit more resistant. So I only spent a few minutes on the right side. I spent about 15 minutes total, and I just wanted to show you that you can characterize this material very easily. And there it is.